Welcome to this Getting Started video using Simon-Kaloi Engineering's PGMR programming utility. PGMR is a sequel to the Programmer. Its purpose is to provide a tool for real-time DMX recording. This covers both animatronics devices, including servos, on-off actuators, and all this is synced to sound, or you can program without a sound source. It also is used for programming dynamic lighting, including dimmer packs, multicolor lighting, and motion control lights. The other purpose for this program is to provide a system test tool. It can check out your system's network connectivity. It can provide remote centralized control of the devices in the network. This includes playing back audio, DMX launching, checking input triggers, and also debugging sequences used by the Minisam and the RPod. Some of the features include this program works with our Minisam devices and the RPod units. The program is Ethernet bus based. It uses a custom protocol called SKE. It's a UDP type protocol that also incorporates FTP, and it allows you to connect to multiple units simultaneously. This protocol includes automatic device detection of units on your Ethernet system, and that will allow you to go out and pull them and select them as you see fit. Also, there is a direct console control that allows you to interface to the device as if you were connecting through the console serial port. The programming primarily allows for two types: a bit level control using the keyboard. This includes setting specific channels, bits, and key map assignments, and also slider-based controls, full range controls using GUI sliders, and these are also channel assignable. You can develop your program synced to an audio source or not. It can be free running. Recording and playback allows for settable start and stop times, single stepping by frames, punching in and out recording, and simultaneous playback and record features. It includes a full program editor, modify functions for the data delete, insert, and time shifting. The final output of the program can be either a project file, which you can load and save. It saves all the settings you last included, and also to export the final DMX binary wave file. It also allows for importing DMX binary wave file, and also you can FTP export the file upon saving it so that you can execute it directly in the unit. So let's begin. I'll start by opening up the PGMR program. In this main window, you'll notice that there's a sound area right here that includes the total length of the program, a media control area that controls the position of both the sound and the control data within the program, and the final area is the keyboard sliders, connections, and command area. Each of these areas is selected by choosing the appropriate tab. So let's start off by establishing a connection with units on our Ethernet. I'll begin by selecting the Connections tab and opening a socket. I'll then poll to see what devices are out there. Currently, I only have one device attached to my Ethernet network, and it's a Minisam 3 as indicated here. It lists the parameters of that Minisam. It tells you how many channels there are, how many tracks, number of subwoofers, microphone, etc. By choosing that the text in this window, I'll establish a connection with that Minisam. We can now test the connection by going to the commands window and typing in a command to that device. I'll try doing a directory. So as you can see, I was able to return the directory of the files that are on the Minisam now. So next, let's open up a sound file. I'll go ahead and browse to my sound files folder, and I'll select Apollo 13. You'll notice when I open the file, it gives the path in this window right here. Also lists the file parameters. This file is a 44.1 kilohertz sampled file. It's 16 bits and a stereo. The total length of the sound file is indicated here. To begin playback, all I need to do is hit the play button. You'll notice that the sound is playing and the current position of the sound playback pointer is indicated here and in the slide bar. I can pause that file by simply hitting the pause button and resume by hitting play again. To stop playback, all I need to do is hit the stop button. At this point, I can reposition the sound to any position within the file. I'll position it here at 149.26 and select play again. Let us now take a look at the keyboard bit programming section of this application. You can do this by selecting the keyboard tab right here. You'll notice that there are 8 rows indicating bits that can be programmed simultaneously. Each one of these rows represents a particular channel bit. This box right here is a record enable. This is a key assignment, whether the channel is punch enabled or not, and the output value when you're programming. So each one of these boxes can be changed to your particular needs. So for example, if you wanted to program channel 2 bit 3, I could simply change this to channel 2 bit 3, and then programming using the A key would correspond to that channel and bit number. Let's take a quick example of that. I'll enable programming on that, and I'll select the record button, and then I'll begin by pressing the A key on and off. Each time I press the A key, the bit will turn on, and when I release the A key, the bit will turn off. Let's show you. Okay, I just performed a simple on-off pattern. I'll go ahead and rewind that, disable the recording, and play it back. You can see that my key presses now correspond to the bit and they're recorded into channel 2. This time I'll record both channels 2 bit 3 and channel 1 bit 2 simultaneously. And this is done by pressing the A and S key. So I'll enable both those bits. Now I'm going to be recording over the previous recorded data that was on channel 2 bit 3. So I'll press the record key again. And you can see I can alternate by pressing the key between those 2 bits. I can have them both on simultaneously, both off. Press them fairly rapidly. Stop. Now let's take a look at the recorded data. You can see that the data I had previously recorded on channel 2 bit 3 has now been overwritten by the new programming data. I'll stop that, rewind it. This time on channel 2 bit 3, I'll go ahead and do a punch-in recording. Now this is done by pressing the shift key during playback. So as I hit the shift key, it'll switch from playback to record, and when I'm finished punching in, it'll go back to the playback mode. Let me show you that. Again, I'm pressing the play key here. It's playing back my previous data. I'll hit punch record, and now I'll replace the program data that I recorded before, punch out, and now when I rewind it, you can see the new data that I had recorded on channel 2 bit 3. This process can be repeated until all the bits you want recorded have been recorded, and they'll be synced to the audio. Next, let's look at the slider section. Slider section right here represents channels only. So it has the same record enable and punch enable, but this applies to all 8 bits of the channel. So in this case, I'll record on channel 3 since we have data on channels 1 and 2. In the case of recording, since I have record and control enabled, I can actually place my mouse over the channel 3 slider, and by hitting the control key I'll start the recording, and I can immediately respond with the slider. So let's start the recording by I'm hitting the control key now. As I'm moving slider 3, it's being recorded. But you can see on channel 1 and 2 that the data is being reflected on that slider. And I'll go ahead and take it down. Stop playback. So now if I rewind it and do the playback, record disabled, we can see that the slider actions that I made are now being played back, along with the data that was on channel 1 and 2. If I switch to the keyboard side, you can see the channel 3 slider data represented in bits. Stop that. Okay, now that we have some data recorded, let's see how we can edit that data. The editor can be launched by selecting either the edit key from the keyboard tab or the slider tab. This window shows the event data. The event data is on the right-hand column. In this case, we have the data from channel 1 bit 2 throughout the entire list. If I wanted to look at the data that was on channel 2 bit 3, I can select the channel 2 from the channel 2 list. If I had more than one bit recorded on that channel, then multiple bits would show up here, and I could select the bit that I'm interested in modifying. For the case of the slider data, that's recorded on channel 3, and we can see the slider data contained on channel 3. The box on the upper left-hand side of that edit window is the selection information. So if I select a range of data right here, it shows me the start time of that selection data. That's 101, the very first frame in the selection, down to 113, the last item in that selection. It also shows the parameters for that first cell selected. In this case, it's channel 3, and the output value is 11. Below the selection area window is kind of the record statistics. In this case, we see that we have 11 items selected in the program list. The total displayed inside the list is 303 events, and the total for the entire program or show is 416. Below the statistics area is the operations that you can perform on that data. The first tab shows the modify functions, the second a delete function, the third an insert function, the fourth a duplicate, and finally the shift time function. Let's first take a look at the modify section. Modify selection allows you to operate on either a single cell or multiple cells that are selected. You can perform a time modification by enabling this checkbox. You can change the channel for the selected range by enabling this checkbox, or the output value by selecting this checkbox. In the case where you have a multiple range of data selected, by selecting the use delta times for a range, it will perform an offset from that first value change. In other words, if I were to, for example, we select the slider data, and I selected from channel 6 to channel 13, or from time 106 to 1013, that's 1 second and 13 frames. I could move that first one back by one location. So if I change the frames to 5, for example, enable time change, I'm going to move this entire range of data from 106 back one. Now you notice that it goes down to 105, all the way down to 112 instead of 13. We can also change the channel that this data resides on. So if I wanted to move the slider data from channel 3 to, say, channel 4, I could select the entire range of data. Let me select the first cell. I'm going to move all the way down to the bottom, holding the Shift key down, selecting the entire range. You can see I have a range of data selected from 0 to 1603. I can now modify that channel data. I'm going to move it from channel 3 over to channel 4. Hitting execute. Now I have that data on channel 4. And we can see the results of that change I just made by selecting play. You now see that the slider data is occurring on channel 4 instead of channel 3. The next function is the delete function. So if we take a look at the first bit data, I'm going to go ahead and select the first cell here. We can see that at the beginning of every recording section, the first location 0 is automatically zeroed in case it had a previous value prior to recording. This was not an event recorded by the key, it was something inserted by the program automatically. This guarantees that the bit starts in an off position. You may not want to do that, however. You may want to retain the previous value that the bit was at and only modify it when the event occurs. In this case, we can delete that first bit frame, and I'll show you that. I'm going to select the first frame. I'm going to select execute, and it will remove that first event frame that sets it to 0. Now, whatever the bit ends at, that's where it will start at. Moving on to the insert function. I'm going to go ahead and select the slider data for an example. Okay. If you remember when I recorded the slider data, I didn't end on 0. I ended with a value of 10. And we can see that here as the last event in the whole frame has a value of 10. If we wanted to make that 0, we could, for example, go down to modify the output value, change that 10 to a 0, and go ahead and change it. Now the slider finishes with a 0 value. Problem is that now we don't have a very smooth transition between a value of 11 and a value of 10. So we might want to insert another value in between that. So in this case, I'm going to go ahead and insert a frame at, move over to the insert function, insert a frame at 1600. And I'm going to choose an intermediate value of, say, 6. Go ahead and execute that. And now I added a new event here with a value of 6. So that's between 0 and 11. That's the insert function. The duplicate function allows you to duplicate a range of bits or slider values to another channel. In this case, let's go ahead and move the slider data that's on channel 4 back to channel 3, but in this case, instead of moving it, we're going to actually duplicate it. So I'll select the very first frame, move down to the bottom, and using the Shift key, again, I'll select the range that selects the entire range of data from 0 to 1603, that last event. And I'm going to go ahead and change the channel to 3 in this case. And so it's going to move the data from duplicate the data from channel 4 to channel 3. I'll do that. Notice that we just added a new channel 3 here. If I go ahead and play that, you can see that we have now duplicate slider data on channel 4 and channel 3. Okay. And finally, let's look at the shift time information. Let's say that on channel 3, I wanted to offset the data. So right now, that data starts at 0. Let's say I wanted to shift it forward by a certain number of frames. So let's go ahead and shift it forward by 5 seconds. Change that to 5. Now it's going to shift this entire, when I hit execute, it'll shift that entire range by 5 seconds. There we go. Now when I play it, you'll see the data shifted. Ready to play. and it finishes. Okay, to recap, we've recorded DMX data and we've gone in and edited that data. Now let's show how we can save this data and create an export file to send to the mini-SAM. To save the project file, you can select File and select Save As. And we're going to go ahead, and I've already created a file for this, but I'm going to create a new one. I'm going to say Apollo Demo. Select Save, and it'll save the project to file. Now later on, after I close it, if I want to come back in and be in exactly the same position I was when I saved it, I can just go ahead and do a open file. So open Apollo Programmer, there we go. When you do a file save like that, it saves all the parameters. It saves your select start, select end positions, it saves your current time pointer, it saves all the options and your slider connections, commands, and keyboard window. It saves the sound file that we're using and its path, everything. The other kind of file that needs to be created is the DMX file. That file doesn't contain any of that information. It only contains the raw hex data in waveform that the mini-SAM or the SLAM will use to play back a DMX file. To save that file, we simply select Export DMX. It brings up this dialog box right here. Now there's a variety of options you have here. You can elect, if you don't select the first option, which is Save Selected Range, it will save the entire file contents, contents of your program. Otherwise, you can select a specific range from channel start to channel end. Another option here is to include the audio file reference. In this case, it's Apollo13.wave. When you do this and you play the DMX file, you don't need to actually specify an audio file to play back. It will go and look on the card for Apollo 13 and play that file when it plays the DMX data, all in one action. As part of this file, you can specify the channel you want the audio file to play back on and the track number that audio file plays back in, as well as the track volume. You can either change the volume by clicking on this button or leave it alone and it will assume the last track setting for that soundtrack. As a final value, we have send file. We can export this file and also send it via FTP to the unit if it's connected. So in this case, I'm selecting the send file to device via FTP. I'm going to select OK for these parameters, and then it's going to ask me for a file name and a location to save that file. I'm going to save it right on the desktop, and I'm going to save this as Apollo DMX.wave. I'm going to select Save, and you'll notice here in the bottom of the screen it shows that the DMX wave file was actually transferred to the unit. We can verify this by looking at the unit. I'm going to do a directory. And if we look at the directory, we can see that, where is it? Here it is right here. Apollo 13 DMX file was transferred to the unit. If you're still around and paying attention, thank you for hanging around to see this demo of the new PGMR program. We look forward to having you use this and give us feedback on its operation. Thank you very much. Bye-bye.